Hello world, welcome back. We are going to discuss on bitwise operators in this video. So basically bitwise operator are used to do bit level operations at the binary level. So before we move forward, let's discuss on how to convert a normal number into binary system or binary number. We have 32 bits or 64 bit system, right? And every operation performed on the lower level is in terms of binary. So let's say 8 empty spaces I am keeping. It contains 8 bits. There are 8 bits here. Similarly, again we will be having 1, 2, 3, 4, 5, 6, 7, 8, another 8 bit, and so on till we get 32 or 64 bit system. Now let's say if you want to convert any number into binary. From right hand side, let me number these empty position 1, 2, 4, 8. I'm just doubling the number 16, 32, 64 and 128. Now let's say I have taken number 5. I want to convert 5 into binary system. Now looking into these empty spaces, how can I sum up these number so that I'll get 5? So if I'll sum up 4 and this one, I'll get 5. So I'm considering 4 and 1. So wherever I'm considering the number which adds up to give the desired number, we will put 1 there. So 4 and 1 I have considered, because 4 and 1 when I'm summing up it is coming as 5. Instead of 4 I will write 1, then instead of 2 I will write 0, and then again instead of 1 I will write 1. So the binary equivalent of 5 is 1, not 1. Let's take another example. I want to convert number 11 into binary. So how will I sum up these numbers so that I'll get 11? So 8 plus 2, 10 plus 1. So I'm considering 8, 2 and 1, which is giving me 11. So whatever number I am considering, I will be writing 1, and rest others I will be writing 0. So I have considered 8, so I will write 1. 4 is not considered, so 0. 2 is considered 1. 1 is considered 1. So equivalent binary number of 11 is 1011. This is how we convert normal number into the binary numbers. Now we can convert the number from coding also if you want to convert any number into binary. So from coding, how we will do that? Let's say I want to convert 11 into binary numbers. I will write down the keyword bin and then I'll provide 11. So once I'll run it, it will convert into binary number. So 0b represent that the output is binary. 1011 is the binary equivalent of 11. Now we know how to convert number into binary. Now let's come back to the bitwise operators. So we have these many bitwise operator. This particular AND symbol represent AND operation, pipe symbol represent OR, cap symbol represent XOR operation, then this particular symbol represent NOT. These two less than symbol represent zero shift. These two greater than symbol represent right shift. Let's understand these one by one. You might have studied the truth table in your college days or school days. If you are considering two operands, then X and Y will be 1 when both of these will be 1. For X or Y, it will be 1 if any of these is 1, and in other places it will be 0. For XOR, when both of the operands have 0 or both of the operands are 1, then it basically returns 0, and in other places it returns 1. And not of X means if X is 0, then not of X will be 1, and if X is 1, then not of X is 0. This is the basic truth table. Now let's do bitwise operation on two numbers. Let's say I want to do bitwise operation on 1 and 2. This AND symbol represent AND operation. So the bitwise operation, when I'm doing, I'll first convert the numbers into binary. So the equivalent of binary is, let's say if I'm considering 3 digit 001, and binary of 2 is 010. And I will be doing AND operation from right hand side. From right hand side, when I'll consider these two digits 1 and 0, 1 and 0 is 0. 0 and 1 is again 0, and 0 and 0 is 0. So it will return me 0. The output should be 0. Let's run it. See, the output is 0. So we have done the AND operation. Let's do the OR operation now. 1 or 2. When I'll do OR operation, so 1 or 0. What is 1 or 0 represent? It will be 1, right? And 0 and 1 is again 1. So this is binary number right now. Binary equivalent of 011 is 3. So when I'll run this program, the output should be 3. The output is 3. So during the process, we have to convert the numbers into binary, and for final result, we have to convert back from binary to normal numeric digits. Now let's take the example of XOR. If I'm doing X of R of 1, and let's say this time I'll take 3. How we'll do that? So first we'll convert 1 into binary. So 0, 0, 1, and binary equivalent of 3 is 0, 1, 1. So when I'll do XOR operation, 1 XOR 1 is 0. You can refer the truth table in the slides that I have shown you some times back. And XOR of 0 and 1 will be 1. And XOR of 0 and 0 will not consider. I shouldn't have written this. So we'll be only considering the maximum digits of the number involved. So maximum digits of the number 1 and 3 involved is 2 digits. So we'll just consider 2 numbers. So the binary equivalent of 1 0 will be 2. So when I'll run this program, the output should be 2. The output is 2. So that's how bitwise operator works. Now let's talk about left shift operators. So left shift operators is represented by less than symbols. This particular thing represents the number on which we want to perform left shift. And this particular number represents by how many bits we want to do the left shift. So how we'll do that? So first convert 3 into binary number in 8 bit. So in 8 bits, equivalent of 3 into binary is this. So when I will shift this, so what will happen? And these consecutive zeros will be shifted again by 2 digits. All of the left hand side is 0, so it doesn't matter. So when I shift it, it will become, and in place of 2 ones, I will represent 0. What is the equivalent of 1100? So 1, 2, 4, 8, 8 plus 4, 12. So the output should be 12. I'm just adding the numbers at one places. When I run it, it should be 12. See, the output is 12. Now let's take the example of right shift. So right shift is represented by greater than symbol, and I have to do right shift on 3 by 1 digit towards right hand side. So this is 3 represented in 8 bits. So when I will shift the number towards right hand side, so I will shift this number to 1 digit, I will shift this number to 1 digit, and this number is the extreme right number. When I shift towards right hand side, as there is no bits towards right hand side, this will be discarded. So the output will be 0, 0, 0, 0, 0, 0, 0 and 1. And the equivalent of 1 is 1 only in decimal. The output is 1. So practice more on left shift and right shift, and do let me know in comment section whether you are able to grasp the concept or not. You just have to practice a bit to understand and grasp this particular topic. Now let me cover bitwise not operator. So bitwise not operator will basically inverse all the 1s to 0 and 0s to 1. Let's say I'm doing bitwise not operation on 2. Representation of 2 in 8-bit system is like this, right? So when I'll do the not of 2, it will inverse each digit. Now this inverted digit basically represents a negative number, right? So this is the equivalent of negative number. 2's complement and negative number I don't want to cover as part of this video, otherwise you will get confused. But the decimal representation of this binary number is -3. So when I'll run it, it's printing -3. Quick tip to remember is that, so whatever inverse you want to do, let's say you want to do inverse on A, so you just take A plus 1 to it and then apply negative sign. So that's a small trick to remember when you are doing the not bitwise operator on any number. That's it for today's video.